Well, it's a real honor and a privilege to be up here this week sharing this video of the Trimble story. For me to have the opportunity to come up here and share. And we loaded it up with glass so that we could see the mountains that surround our campus. And here you can see the concept design in the context of that survey information that we had just captured. We then take that concept design and we liberate it into the Trimble. This constructible model is done in Building Information Modeling Software, or BIM as we call it. So here is the structure for our facility starting to take shape. And what makes this a constructible model is the fact that it has every single element necessary for fabrication and construction in there. So you can see it's got the rebar, nuts, bolts, welds, gusset plates, everything we need to know to construct. We're doing some of the exterior design. So the pavers, the hardscapes, the planters, everything that was going to be on the outside of our building can be designed in this application right here. Once that exterior design was finished, we send it these machine control devices. They're actually going to receive the design and see it superimposed within the cab of their equipment. Next, we've got two Trimble GNSS receivers on the blade of this dozer, letting the operator know exactly when and how much to engage the blade for an optimum cut every single time. That allows us to save fuel in the equipment and extend the life of the equipment. After the bulk excavation is complete, we can send it on to a motor grader. This motor grader has a receiver mounted on the blade, and this is where we do the detail work, down to the millimeter level of accuracy with that piece of equipment. Next, the compactors start to come in, and they can see inside the cab of their equipment whether or not they're receiving the spec level of compaction. So as they pass back and forth, they're trying to get that color map to turn green to show them they've achieved spec. Once we have achieved the compaction, we can start to send it on to one of our precision paving technologies, which is what you see right here. Now this piece of equipment is actually being fed by one of those robotic total stations there in the background. And that robotic total station is letting the equipment know exactly where it needs to be at every moment and where to lay down the material. So again, trying to optimize the utilization of our material out there on site. And if we can see a dispatcher sitting in his office, receiving the order, and then sending a truck with the material out there to site. He can see in real time the status of that truck at any given moment. Here's our concrete truck coming up Westmore Drive and starting to arrive at our site. Mounted inside that truck is a device where the operator is able to send status updates back to dispatch with just the push of a button. This kind of technology is really essential when you think about perishable materials such as concrete or asphalt, which could cure or harden during the transit process. So lucky for us, the truck got out there in time. We were able to start pouring our slab on grade. So here we go. We're getting the foundation in place. Also lucky for us, that guy got out of the concrete before it's set up, so there's no one buried under our Westminster building. Don't worry. And then our foundations were ready. So we're ready to start moving on to the superstructure phase. But before we do that, we're going to take a look at that flow line schedule once more. So here's that flow line schedule, again being fed by the constructible model. We're going to drill into the next phase of construction. And we can even see that in our 4D simulation, which is an integrated byproduct of all this technology. And now we're going to kind of zoom into the second floor, and we're going to see some of the layout solutions in action. So again, we're using that constructible model, and in this case, we're getting the points for the core walls. So these are the walls that are going to encapsulate our elevators, and they're being laid out by that robotic total station. That robotic total station can also send the design information into one of our mobile tablets, which is what you see right here. So on this device, as this gentleman walks through the building, he can start to experience an augmented reality. By that I mean that he's able to see design information from within that tablet before it's placed in the field. And there, he spotted a conflict. As is often the case in construction, sometimes things get out of alignment. So he takes awareness of that misalignment and he sends it on to the designer for an update. So now we go back into the design software and we make the change. We're getting the wall moved into where it needs to be. We're going to take the electrical panel and the switchgear and get it mounted on the new position in the wall. And from within that design software, we can send the update right back up through the Trimble Connect environment and then back down to that mobile device. So as long as that mobile device is connected to a network, he'll receive the design update instantaneously, and he can see that that wall is now fixed up and where it needs to be. So with that update in place, we were able to get our panel and our switchgear in there without having to do any rework, without any lost efficiency out there on site. Again, we're going to go back to the flow line schedule and determine what activities need to be done next. Check the 4D simulation to see where we're supposed to be in our progress. And now we've got a little bit of work to do up here on the roof. So in this case, we're setting a beam for our parapet wall that encapsulates the cooling towers. Now this beam has a lot of history before it got out there on site. It had to be detailed, fabricated, loaded, unloaded, and Trimble has a mobile material tracking technology that we use for tracking that beam through its life cycle out to the project. We also use one of our mobile technologies for inputting in the production. So as elements get placed, whether it's a beam or concrete or studs, we can put that information into one of our mobile solutions, and we can start to proactively manage our project based on the actual performance that we're achieving out there on site. So now our beam is getting set, and while that's happening, there's another crane on the other side of the building. Now this is a crawler crane. Crawler cranes are very large, very heavy pieces of equipment, so there are some safety implications with that. To address those safety implications, we have this LSI technology that's mounted inside the crane cab and also on the boom. This technology lets the operator know exactly where his boom is at any given time. So the slope, the swing, the slew, and even the tension that he has on his hook at any moment. It's also making him aware of overhead obstructions. So if you remember, we have the tower crane swinging on the other side of the building. The operator is getting a real-time alert in his cab that there's a potential conflict coming up with the two booms. So we can prevent a collision out there on site. So flash forward just a little bit. Our building is completed. We're going to capture all of that as-built information with one of those 3D scanners that you can see out there on the floor. We're going to store all of that as-built information into the Connect environment, and then it's time for us to take ownership of this building. So as the owner-operator, we really want to be efficient with this facility because we're going to have it for a long time. So to help us with that, we have another technology here which is called IWMS, or Integrated Workspace Management System. So this is one of our building managers sitting in the lobby area, and he actually just received a work order ticket on his mobile device about something in the building that needs to be fixed. You've been to Westminster, this is going to look pretty familiar to you. So now, using some of our visionary technology, he's actually tracking through the building to find this element that's in need of repair. As he starts to round the corner, he can see that it's a P-trap that needs fixing. So we've got a pipe that's connected to our plumbing system. Maybe it's become clogged up. He's going to go in there, make that fix, and as soon as he does, he's going to log that fix on his mobile device so that awareness of that fix can live and persist with this building forever. And any other building manager that needs to go in there and make a fix in the future will know how we repaired it in the past. So as he starts to round the corner and come out to the lobby area, he's going to see another one of his colleagues connected to that IWMS. And this gentleman's booking a conference space. So he's looking on his mobile device, he's finding all the available rooms in the building, he books his conference room, and immediately that information syncs up to the master database. So now the building manager knows in real time all of the spaces that are occupied, vacant, potentially under construction or in flux, everything we need to know to efficiently manage our space. And normally, this is where the story would end. But luckily, Trimble is actually growing so fast that I'm pleased to let you guys know we're already working on phase 2 out in Westminster. So stay in touch with us, stay connected, and find out how over the coming months and over the coming year, we're going to use 75 Trimble technologies to continue to raise the bar and set a new precedent in